Hello friends, so welcome to uh, another day 11 for solving problem of the day from GFG. So let's look at the problem. Okay, so given an array of integers and an integer k, find all the pairs in the array whose absolute difference is divisible by k. Right, okay, it's very simple. So let's understand the problem by an example given in the question. Yeah. So what the question is basically saying is that we have given an array, right? 3, 7, 11. We have to give how many pairs are there, how many pairs are there whose absolute difference is divisible by 3. Okay. Suppose here for this case, for this array, if I take these two elements, 3, 7, so their absolute difference is 4, right? So, oh sorry, the absolute difference must be divisible by this k, right? So k is given as 4. Yeah, and if I take these two elements, so this pair 3 7 with absolute difference 4 is divisible by 4. So this is my one pair, right? So if I take 7 11, then their absolute difference is 4. So this pair is also my answer. If I take 3 11, their absolute difference is 8, right? So 8 is divisible by 4. So this is also my answer. So I have to give the number of pairs. Okay, so here the pair are 3 pairs I have, right? So my answer is actually 3. So I don't have to count 7 3 as my another pair. This is to be noticed. Okay, I don't want to count 11 7 as my another pair. I don't want to count 11 3 as my another pair. Okay, so these are not gonna be count in my answer. Okay, so 3 7 is equivalent to 7 3, right? So pair means that. All right, so let's take another example. Suppose 1 6 7 9. Okay, so this is my given array. Suppose my k is 2. Okay, yeah. So how many pairs are there? Let's check. So if I take these two, so 1 5, so the absolute difference is 4, divisible by 2, right? It's okay. If I take these two, 6 minus 1 is 5, not divisible by 2. If I take this one and this one, 7 minus 1 is 6, right? So 1 7 is my another pair. So 1 9, yeah. So 1 9 has an absolute difference 8, which is divisible by 2. So these three are my answers. And if I take 5 6, difference of 5 6 is 1, not divisible by 2. 5 7, yeah, 5 7 is one pair. 5 7 is one pair whose difference is divisible by 2. 5 9, yeah, 5 9 is also my answer. So 5 9 has an absolute difference 4, which is divisible by 2, right? So if I take 6 7, 6 7 doesn't work. 6 9 doesn't work. 7 9, yeah, so 7 9 is my another answer. 7 9 has an absolute difference 2, which is divisible by 2. So the total answer is here 1 2 3 4 5 6. Okay, so I have 6 answers, right? So this is by brute force approach, right? So I am taking this element and checking for this one, this one, this one, this one. Does any of them pair with 1 to make a number divisible by 2? Okay, then I take this element and I take all these elements to check if any of them any of them makes a pair with 5 to create a number divisible by 2. then I take 6 and check any of these numbers makes a pair with 6 to make a number divisible by 2. Then I check for 7, then for 9, 9 has the last number, so don't have to check that. So this is basically O(n) square approach, right? I will create a for loop, then again a for loop, then I check that if our difference is divisible by k or not, right? So this is a O(n) square approach, right? So I don't want that O(n) square approach, so I want to do it in O(n) approach. So how can I do that? So this is the question. Okay, so nothing to think about that much, it's very easy. So let's come into that now. Okay, all right. Now what I'm going to do is I'm going to tell you one thing which is which belongs to modular arithmetic. Okay. So modular arithmetic, what is that? We use this module operator, right? You know that what it means. So a modulo b means the remainder after after dividing a by b, right? So if I divide a by b, I will get some result and I will get some remainder. This remainder is my a modulo b, which is a modulo b is giving, right? So this is the thing that a modulo b gives. So in another way, actually giving the remainder, right? So what does the modular arithmetic is saying? That I can write this in another way, that a modulo give me r. So I can write this in another way, like a is congruent to r mod b. Okay, that means that when dividing a by b, I will get a modulo, I will get a remainder r. I'm saying once again, a modulo b is giving me r. That means when I am dividing a by b, I will get a remainder r. This is another way to say it. A is congruent to r modulo b. Okay. So now what I want to tell you is that suppose I have two numbers. Okay. So actual definition of this is a congruent to r mod b is equivalent to saying r divides b minus a. Why so? Because after dividing after dividing a by b, I will get a remainder r, and suppose my result is suppose it is x. So I can express this as a equal to bx plus r, right? Equal to bx plus r. All right. So yeah, it's fine. All right. Yeah, so I have made a mistake here. It's equivalent to saying actually b divides a minus r. Okay, so look at here. So I divide by b, I get a remainder a, and my result is x, right? So suppose I am dividing 7 by 2, I get 2 3s are 6 and a remainder 1. So I can write 7 as 2 into 3 plus 1, right? So that is I am doing b into x plus r. So if I take this one in my left side, it is a minus r equal to bx, right? It's a minus r equal to bx. So a minus r equal to bx means a minus r by b equal to x. Now x is an integer, right? It is an integral value, or you can say is an integral value, right? So it's an integer. That means this part is an integer. If you are saying something equal to something, that means that if it is an odd number, it will definitely be an odd number. It is an even number, it will be definitely even number. If it is rational, it's rational. If it is an integer, it is integer. If it is something, it will be that something. So here, if it is an integer value, it will be integer value. Okay. So that means after dividing a minus r by b, I will get an integer value. So that means b actually divides a minus r. Okay. So that is what I am saying. That if b does not divide a minus r, if b does not divide a minus r, I will definitely get remainder in that case. So actually in that case a minus r by b is not an integer, right? So if I say 7 by 2 is not an integer, that means 2 doesn't divide 7. If 2 divides some number x, then definitely this is an integer value. Why? 2 divides some number x, suppose x equal to 4. So 2 divides 4. So that means our result is an integer. So in that, because all of them are integer, a, r, b, all x, all belongs to integer. Okay. All belongs to integer. So I can write like this. So what I am saying is that b divides a minus r. So that is the thing. Now that is the thing. Okay. So a congruent to b equal to r is equivalent to saying is congruent to r mod b. Yeah. Suppose I have two numbers x and y. Okay. X and y. And if I divide this number by suppose some number k, and if I divide these numbers by suppose k, then suppose I got some r1, and in this case I got r2. If k divide y, r2 will be 0. You got no number, there is no remainder, right? If k divides y, r2 will be 0. If k divides this, r1 will be 0. What I am saying is that, okay, so this is not equal to, what I am saying that after dividing x by k, I get a remainder r1. Okay. I get a remainder r1, and after dividing y by k, I get a remainder r2. So obviously x by k, or I can say, so what I have told you is, if I divide a by b and I get a remainder r, that means a equal to b into some number x plus r. So here compare this thing. So x equal to k into some number, suppose m plus r1, and here y equal to k into some number, suppose n plus r2, right? So yeah. So now what I want to say you is that if suppose I subtract y from x, and I am telling you that if I divide x minus y by k, I will get a remainder r1 minus r2. That is why I am telling you. This is my claim. Okay. This is I am going to prove it. Right? It is what I am going to prove it. Now see that what is x minus y? It is km plus r1 minus kn plus r2. Right? This is my x minus y. Now this is equal to km plus r1 minus kn minus r2. Now this is equal to km, take k from common from this km, it will be m minus n plus r1 minus r2, right? So now if I divide x minus y by k, I will get what? K m minus n plus r1 minus r2 by k, right? So this is actually equal to what? It's actually equal to r1 minus r2. Why? Why so? Why so? Take a number. Suppose this number is my p, and this number is suppose q. So one thing to notice here is that a remainder is always less than the divider. Okay, so r1 is less than k, and also r2 is less than k. So what I want to say, if you divide something, you divide some number by 2, you will definitely get a remainder of either 0 or 1. You cannot get a remainder of 3, right? If you divide something by 100, you will get a remainder of 0 or 1 or dot 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 or 99. You will never get a remainder of 101. Why? Because then you will again divide 101 by 100 and you will get a remainder 1. So that is why. Okay. So if you divide 7 by 3, you will get a remainder of 0, 1 or 2. So you can get a remainder of 0 or 1 or 2 up to that number minus 1, k minus 1. So if you divide some number by k, we will get a remainder from 0 to k minus 1. Okay. So that is why I am saying that here r1 is less than k and r2 is less than k. Okay. So that means r1 minus r2 is less than k. So if you divide some number which is less than k, it will be that number actually. Okay. So if you divide 1 by 2, it will be 200 and 1, right? So we will get a remainder of that number. So if I divide some number by k by some if I divide some number which is less than the divider, here this is my what I am just doing the division by. So r1 minus r2 is less than k. So if I divide a number by a bigger number than it, if I divide a number by a bigger number than it, then I will get a remainder of this. I will get a remainder exactly this. Okay. So if I divide r1 minus r2, I will get a remainder r1 minus r2. And in our case, r1 minus r2 is less than k. So if I divide r1 minus r2 by k, I will get a remainder r1 minus r2. Right? So here q is less than k. Right? This is to notice. So this is p, this is q. So I am dividing by k. This is my xy by k equal to. So this will be kp by k plus q by k equal to. So I am calculating the remainder, okay, not the result. So why I am doing the equal to sign? I am not computing the result, okay. This is my x equal to x minus y. That is okay. This is my x minus y. I am what I am calculating here? The remainder. What is the remainder after doing x minus y by k? So this is equivalent to this one, right? So x minus y by k is equivalent to this one. That is right. So x minus y by k is equivalent to this one. That is also right. That is also right. Okay. So this is equal to x minus y by k is also equal to kp by k plus q by k. So when you divide k by kp, when you divide kp by k, obviously you will get remainder 0, because this number is a multiple of k, right? This is kp multiple of k. If you divide a number by that number by some number of multiple is that number, so you will get remainder 0. Suppose 2 into some k, you are dividing by 2, you will get remainder 0, because 2k you are dividing by 2, so 2 k's are 2k, so remainder 0. That is what I am saying. This remainder is 0 and this remainder is q, so you will get q, which is around minus r2. Okay, that is what I am saying. So this is the more or less part what I am trying to do, that you can see this. Okay, so the thing is that suppose x modulo k, so so first let me do this in that way. So I divide x by k and I get remainder r1, and I do y by k and I get remainder r2. Then if I divide x minus y by k, I will get remainder r1 minus r2, right? This is equivalent to write as if I do modulo k and it is equal to r1, if I do y modulo k and if I got r2, then if I do x minus y modulo k, I will get r1 minus r2. Okay, so this is equal to sign is valid. Here I am just calculating remainder, but in this case it actually giving me the remainder, so that is why I am doing using equal sign. So that is the thing, that is the most important thing. Okay, so now in our case what we will do is, let me just yeah. So now here what I will do, I'll calculate for each element. Suppose this array, this name is array, suppose the name of the array is ARR. So we'll calculate ARR I modulo k, right? So for this, suppose I will get 1, 2 to the 4, so 5 modulo k is 5 modulo 2 is what? 1. I will get 1. For this one I will get 0. For this one I will get 1. For this one I will get 1. So what we will do that, so remember what the question is saying to me, the absolute difference of any two element should be divisible by k, right? Should be divisible by k. So what I am trying to say is that suppose I have two elements, x minus x and y. Okay, I have two elements in my array, x and y. I will say that these two elements, when I am doing absolute difference, when I will do absolute difference, I will get a multiple of this k. I will get a multiple of this k, suppose mk. So this is equivalent to saying that if I divide the absolute difference by k, I will get a remainder 0. This is equivalent to saying that if I divide x minus y by k, I will get a remainder of x modulo k minus y modulo k. That is what I have told you, right? If x modulo k, yeah, so if x modulo k is r1 and y modulo k is r2, and suppose r1 equal to r2, so what will be that case? So the first thing I have told you, that if this is the thing, then x minus y modulo k will be r1 minus r2, right? Now take a special case as r1 equal to r2. What will be then? So x modulo k equal to r1 and also y modulo k equal to r2. then x minus y modulo k will be r1 minus r1 equal to 0. So that means, so saying the absolute difference is divisible by k, I am saying once again, saying absolute difference is divisible by k is equivalent to saying the difference is divisible by k. So there is no thing. Okay, so much. So what is it saying? That x minus y modulo k is 0. It is saying that x minus y is divisible by k. So that is the what I want to do, what I have to do in this question. The question is asking for the pairs whose absolute difference is divisible by k. I turn them into, the difference is divisible by k, and I turn them into this part, that x modulo k, if it is giving me some remainder r1, then y modulo k will also give me a remainder r1. Only in that case this thing will happen, that absolute difference is 0. All right, I have shown you now. So that is the thing. So I am saying once again, if x by k is giving you a remainder r1 and y by k is giving you a remainder r2, then x minus y by k will give you a remainder of r1 minus r2. Okay, so if r1 equal to r2, if r1 equal to r2, then x minus y by k will give you a remainder of 0. So that means, okay, so what this thing means? This thing means x modulo k equal to r1. After dividing x by k, we will get a remainder r1. What is this thing means? This means y modulo k is equal to r2. So if I say that r1 equal to r2, is not the thing that x minus y modulo k is equal to r1 minus r2 equal to 0, right? So that is the thing I want to say, that if two elements are there, suppose x and y, and I got the x modulo k and y modulo k values, suppose they are suppose p and q. So if p and q are equal, what are they after doing x modulo k and y modulo k? Okay, so there was x and y. What I have done? I have done x modulo k and y modulo k, and I got p and q, suppose. So if p and q, this is p and this is q, if p and q are equal, then obviously x minus y modulo k is 0. Obviously this will be my answer. That is what I am saying. I have a pair xy, I convert them into x modulo k and y modulo k, and I got two same number, and definitely x minus y will be divisible by k, or I can say x minus y, or their absolute difference, whatever, modulo k will be 0. Or this is equivalent to saying that x minus y is a multiple of k, right? So x minus y by k, so x minus y divisible by k, that is equivalent to saying x minus y is some multiple of k, right? So that is what I am saying. If p and q are equal, so p and q are equal, then x minus y will be divisible by k. That is, this thing will give me a 0 value. So the conclusion is that pair xy will be my answer when after converting this into y modulo k and x modulo k, I will get to same value. Suppose p and p, I will get a same value, then it will be my answer, because then x minus y will be divisible by k. I have to find the multiples of k. So if x minus y divisible by k, x minus y is obviously a multiple of k. So this thing is important. This thing is important. So that is why I am doing modulo of k for every element. I get the remainders as this, and see here, I get this one and this one as equal elements. So I got one pair. Then I'm checking. So up to here I got one pair. So here it is not equal, here it is not equal. So I will create a map actually. I will create a map that I will. So I have told you what is a map, right? I've told you what is a map. So map contains keys and values. So for 1 it will be 1 2 3 4. It will store the frequency of that element, and for 0 there is 1. So what I will do is I get a 1, I will start searching for here. I get a 1, okay. I get another 1. So two values are equal, I get one pair. So there is a count variable, suppose, which is 0. It will be converted to 1. I get another one here. So up to here there is one pair. Here I got a same value by searching with my map, hash map data structure. So I got another one. So this one and this one will make a pair, and this one and this one will make another pair, right? So I will just check the number of ones before this one. Before this one, how many number of ones are there? So that many number of pairs it will create with this one, okay. So what I'm saying is 1 1 0 1 1, right? So after getting this one, my answer is still 0. My answer is 0. Suppose I get this one, I will update it 1. I will get 0, not update. I will get 1. So before this I get one pair, right? So I get one pair. So what I will do, I will check the number of ones before this. So I will get this from my map.get method. So there is 2 ones before this. So that means it will create a pair with these 2 ones. So my answer updated to that by, so my answer is updated by, see, up to here there is one pair. Up to here, this one will create another 2 pair with this one. I get that from the map.get value. So I will plus 2 here. I will do plus 2. For up to here I got this one and this 2. So there are 3 pairs. Then I check this one as my another one. So I will check how many ones are before this one. So there are 3 ones. So for each one it will create a pair. So I will add 3 here. So then I will get 6 as my answer. So actually there are 6 pairs. That is when doing the absolute difference part, get a remainder multiple of k. Thing here, okay. Right. So if I have 1 1 0 1 1, I got this one, doesn't do anything. I got this one, count the number of ones before 1, there is 1 1. So I will add 1 to my answer. There is no answer. Answer is 0 firstly. So I will add 0. So I will add 1 to my answer. The answer was initially 0. I will add 1 to it. Then I got another one here. So I will check how many ones are there before it. There are 2 ones. So for each one it will create a pair. For this one, it will get 1 1 as pair. For this one, it will get 1 1 as pair. So I will add 2. So I will add 2. 0 plus 1 plus 2. I got another one. So for this one, I will check how many ones are there. There are 3 ones. So for each one, this one will create a pair. So I will add this to my result. So this is my result as 6. So I hope you understood. So let's code now. Okay. So let's quiet this thing. Let's do coding. So first, I have this is for your answer, okay. So I will assign 0 plus 1 plus 2 in my answer. Integer and integer, right? then what will I do? Loop will be going up to n, creating a loop. Then what I will do, I will find the number of ones before me, so that I can get by map.get or default of. Okay, so firstly I have to just what I have to do, I have to do the modular part. So every element will be replaced by its modular part. So every array I will be replaced by array I modulo k, right? So array I will be equal to or I can do delete. Okay, so let's do that. Array I modulo k. Okay. Now we'll do this thing. So I will get the value of I will get the value. So I will check before me, is there any ones? Before me, is there any ones? Okay. So if I am the first one, so there is no before, like, right? So if I am the first element, there is no before. So that is why I am taking this get or default, because for first one I will take as number of ones my before me as 0. Okay. So I will take this value, okay, then I will add it. So I got the number of ones before me, so I will add it to my answer, right? And I will update, as I am also a 1, I will update the maps key by 1. So before me, suppose there are 2 ones, so I am now new one, I am a new one. So for my next elements I have to give my count in addition also, right? That is why I am just updating the number of ones up to me. Okay. So this value, so number of my value, I will update this by 1. Alright, then I will return my answer. Okay, let's compile it. Yeah, it's running. Let's submit it. Yeah, so we got it. So I hope you enjoyed it. So if you enjoyed it, please share the videos and subscribe if you want. If you like the channel content, so obviously subscribe the channel and like my video and just share. Okay, so let's see you in the next video.